Hi guys, we are doing indicator 32 today, and indicator 32 is all about surface area. And in indicator 31, you did volume, and now we're going to do surface area. So let's see what is the difference. But our learning target, I can create nets from prisms and pyramids. I can calculate the surface area of prisms. I can calculate the surface area of pyramids. Okay, so that is basically my learning target for this one. So let's look at this. And during Christmas, you get a lot of these gifts. Okay, so the bigger the size of the gift, the more excited you get thinking how much there is inside. Okay, so remember, everything inside the shape is going to be volume. But when we talk about surface area, it is the area of, think about if you're using wrapping paper. Okay, wrapping paper is not being stuffed inside a box, right? It is used to cover the outside of the box. So you have to know the area of that. And a box or a cube is nothing but a square prism, because the base is the same thing as the top. That's what a prism is about. You have rectangular prisms. I'm going to show you that. I'm going to show you triangular prisms. You have pentagonal prisms. The base of the prism determines what kind of a prism it is. But in a prism, the base and the top are identical. Okay? So now, once again, we are going to surface area, and surface area means the area outside of the faces. Now, we don't call a three-dimensional surface, we don't call that sides. Like in two-dimensional shapes, we say the side of the square or side of a triangle. But in this, because it's this whole thing, it's that means it has 6 faces. Look, 1, 2. So top and bottom. You have the front and you have the back and you have the side and you have another side. So that is 6 faces. Okay. So the surface area of a three-dimensional figure is the sum of the areas of its faces. And since we are finding the area of each, how much is this surface? How much is this surface? Now think about if you're painting a room, you're painting the walls. So that is how much paint would you require for that area. Okay. Tiling of the floor. Bricks on the wall, how many bricks do you need for that wall, etc. So that's where surface area comes in. And because it is the surface, you're finding the area, the measurement is in square units. Okay, inside is volume, so that is cubic units, everything to fill in. But outside, because you are measuring just all this, that is surface area, and so it is in square units. Okay. Now, when you take a three-dimensional shape and when you flatten it out, just think about if I open this box, look, this is what I'm going to get. Okay, so it has 6 faces because look, 1, 2, 3, 4, 5, and 6. Okay, so this is a side, this is a side. This is the bottom here, that's the top. You have a front and you have a back. Okay, so that is 6 faces. So when a three-dimensional shape is opened up like this, it becomes a two-dimensional shape, which is called a net. Okay, so the net of a shape is different, whether it's a triangular prism, whether it's a rectangular prism, whether it is a square pyramid. So these are the things we are going to be talking about. If you look at the net of this one, okay, which is a rectangular prism, this is what it looks like. Think about when you have gone to any of your favorite pizza place, whether it's Pizza Hut, Domino's, Papa John's, Marco's, wherever, okay, whatever your favorite pizza place is. But if you've seen people take a carry out, or if you yourself have done a to-go box, and when they, pack those pizzas, those boxes in the beginning are kept straight up on the shelf like this. But when your pizza is ready, they fold it up and it becomes a 3D shape. which can hold your pizza. Okay, so that's a prime example. But any box is going to open up like this, which has a rectangular base or a square base. Okay, and it's a prism. So look over here, any box. Look, as I said, you have see, you have the front of this, you have the back of this. So look, front and back. You have two sides, this side and this side. Okay, so there you go, the two sides. And then you have a top and you have a bottom. So top and bottom. So this is what the net of a rectangular prism looks like. If I take the 3D rectangular prism and I open it up, this is what it's going to look like. But otherwise, it could look like this. These are all made by students, by the way, because I give you these. All right. So just want to show you, this is a square prism because you always look at the base to determine, and we had talked about this yesterday. This is a square prism because that's the base, and then the top will be exactly the same. All right, this is a rectangular prism. Look, rectangle is the base and the top is exactly the same, so that's a rectangular prism. All right, then we have we have a triangular prism. Because the base is a triangle, so is the top. Okay, and I had talked to you yesterday about best example for this would be a tent if you like to go camping. I'm not a camping person, but there are a lot of people who do like to go camping, all right? So then you look at the base and then you look at the top, and that determines what kind of a prism it is. This is a triangular prism, okay? Now, this one, look, it is still a prism because you have a base and you have a top. So then you count how many sides, and you have 1, 2, 3, 4, 5, 6. So what has 6 sides? A hexagon. So this would be a hexagonal prism. So determines the base determines what kind of a prism it is going to be. Okay, just want to show you that. Let's quickly show you the difference between a prism and a pyramid. Okay, so now look, in the prism, whatever my base is, my top is the same. In a pyramid, I have a base. Now this is a square pyramid. Again, the base determines what kind of a pyramid it is. But look at the top. There's no same top like there was here in a prism. The top is pointed like a mountain top. It's going up. Think of the Egyptian pyramids. Okay, so you have a base, but on the top it is tapering up. So that's what makes it a pyramid. And this is a square pyramid. Okay, this one here would be a triangular pyramid because look again, it's not like a prism. In a prism, look, this is a prism. You have the base and you have a top, which is the same. In a pyramid, you have the base, but in the top, it's tapering. So that is the difference between a prism and a pyramid. Okay, so I just want to show you these shapes before we got into this. Here's another example of a triangular prism because top and base and top, same thing. All right, now let's go ahead and look at the nets. If I was to open up a triangular prism, so you can see what it's saying. A triangular prism is a three-dimensional figure that has 2 triangular faces. Remember, in 3D shapes, it's got its faces, okay? So 2 triangular faces and 3 rectangular faces. The base is rectangular over here, like not base, but you know, let's say if this is the tent, put like this, okay? But otherwise, this is actually the base. All right, so the base, you'll have 2 which are identical and the triangular part, and then you have 3 faces that are rectangular. Rectangular meaning they don't always have to be identical. They can be irregular. You can have different, one can be slanted more, one can be less, you know, so therefore that slope can vary, okay? And then you have a square pyramid, which is a 3-dimensional figure that has 1 square and a square face, and it has 4 identical triangular faces. This is really, I mean, they're all easy to calculate, but this is the easiest. Okay, so these are made by students in the past. This is a square pyramid. triangular pyramid, you know, so all that fun stuff. Okay, now so this is what the net of a rectangular prism. If I open it up, if I open this up, this is what it's going to look like. If I open up flat a triangular prism, this one, okay, this is what it's going to look like. It has a bottom, okay, so here, then it has the sides, this side and this side, and it has the front and it has the back, okay, which are the same. So these are triangular, all right. And then if I take a square pyramid and I open it out, this is what the net looks like. You have the bottom, which is square, and then when I open it, it looks like a flower. Okay, so these 4 triangles will open out, and each of these triangles have the same measure. So this is what the net looks like. Okay, so what you're going to do now, we are going to solve some problems on finding the surface area of these shapes. Okay, so I am going to erase this, and you are welcome to use a net to, you know, label your parts, but I'm going to show you another simpler way also, which my students have always loved in the past, so it will be helpful for you. Let me go ahead and draw a prism. Where did I put the marker? My goodness, here. All right, so let's say I have a prism and it is like this. Okay, so I have a prism going on over here, and this is 7 inches, and this is 4 inches, and this is 3 inches. Okay, and this is 3 inches. So just to make it more visual for you, let me go ahead and just show you. This is one color, okay, and let me show you with a different color here. Okay, and then I'm going to show you. So you can see what I'm talking about. All right. So if you look at this one, this is the front, and because it is a prism, if there's a front, there's a back. Okay, so if I calculate the area of the front, it has to be times 2, because if I have this here, I have the same thing at the back, which I can't see in this. All right, so automatically I know that it's a hexahedron because it has 6 faces, and so that is why I have got to calculate 6 faces over here. Okay, now then if I have a side here, I have another side, so I'll have to calculate 2 of that. If I have a top, I also have a bottom, so I'll have to calculate 2 of that. So when I'm saying sides, look at the blue. When I'm saying top and bottom, look at the red. When I'm saying front and back, look at the green. Okay, so let's do this. Now either, yes, you can definitely make out your, well, you can write the net like this. The front was green. The side over here is shown in blue. Then I have another side. I'm making the net right now, guys. Then we have the back. If I have a front, I have a back. And then I have the top and I have the bottom. Okay, I have the top and I have a bottom. Okay, so this is what the net looks like. This is my top, this is my bottom, this is my back and front. This is opened up like this, okay? And then I have the side and I have another side, Okay, now either I can write the measurements on this and then calculate, or I'll show you another way also. Okay, my students really like this way. What I just do, because I know that yes, this is the net, you're free to use this, and I'll show you how you write the measurements there in a minute. But you can also easily break it, because I know there are 6 faces, right? Front and back, front, back, top, bottom, side, side. So there are 6 faces. So that means, and these are rectangles. So what is the area of a rectangle? Length times width. So I will have to calculate 6 length and widths. Okay, length times width. So 6 areas. So I can just go ahead and, guys, I'm going to remove this because we've talked about what these things are. And I'll do the calculation on this area. But I can just go ahead and make 6 rectangles. 1, 2, 3, 4, 5, 6. Okay? You are free to call it, if I want the green one, I know this is front and back, okay? Then I have a top and I have a bottom. So this is what I'm calculating. I don't care if you break it apart like this to make it easier on yourself. And then you have a side and you have another side. So guess what? Because I have 6 faces, I have to calculate 6 areas. Now, in order to do that, let's look at the front and let's look at the back and write those measurements. Okay? So, look at the front. This is the green. Okay? Area of any rectangle, you've done this in the past, is length times width. Okay? So when I'm looking at the green, look, I'm going to write the measurements here. My length is 7 inches and my width is 3 inches. Whatever is in the front, the back is the same thing because it's a box. All right, 7 inches and this is 3 inches. So let me write all the measurements first. Then, and you can do it here also. You can do 7 inches and you can do 3 inches. Okay, and this is 3 inches. Same thing over there. All right, so this is going to be 7 inches and this is 3 inches. Since this is a box, everything down, since in the rectangular thing, this will all be 3, 3, 3, 3 because it's a rectangular shape. Okay, so you can write it like this, and if this is 7, we know this is 7. Okay, you're free to put it over here or, do it like how I'm showing you. Okay, now let's look at the top. If this is 7 in a rectangle, this will obviously be 7 because it's a rectangle, all right? And then we are trying to find the measurement of the top. So length times width. So if this is 4, obviously because this is a rectangle, this is also going to be 4. Okay, so for the top and bottom, my measurements are 7 times 4. So 7 inches and we have 4 inches. Then we have 7 inches because whatever the top is, the bottom is the same thing, 4 inches. Okay, and for the side now, if this is 4 here, we already have that. So it's going to be this times this. Now, if this is 3, obviously, because it's a rectangle, this side will also be 3. So my side measurements, which are the blue, are going to be 4 inches and 3 inches. 4 inches and 3 inches. Now when I have all these measurements, you are set. Guys, you are free to please put your measurements here also. You can do one or the other, but if you prefer to do it the net way, that is fine. If this is 4, this is 3. Okay, same thing here. This is 4 and this is 3. All right, and then we said top is 7 and then we have this is 4 inches. Okay, same thing here. This is 4 inches and that's 7 inches. So you are free to write your measurements here to solve it, or you can break it apart like this. Okay. Now, when broken apart, to find the surface area of this rectangular prism, surface area, okay, which is S, this is equal to area of top plus area of bottom plus area of, I have the front plus area of back plus area of side and area of another side. So I should have 6 faces. 1, 2, 3, 4, 5, 6. Okay, so let's find the area of the front. Okay, so front, this is going to be, again, see, length times width. So 7 times 3, which is going to be 21 inches squared. Okay, back is the same thing. 7 times 3, which is 21, again, inches squared. And I will write that unit at the end. Make sure that you write the unit. Right now, we're just doing the calculation, okay? Area of the top, 7 times 4, which is 28. And bottom is the same thing, 7 times 4, which is 28 inches squared. And then we have a side, which is 4 times 3, which is 12 inches squared. 4 times 3, which is 12 inches squared. So now we found all the areas of those 6, and now we've got to add it up. So surface area is equal to, we have 21 plus 21 plus 28 plus 28 plus 12 plus 12. Okay, and now all you do is add them all up, and when you add them all up, you get 42, 52, 62, 64, 28, 28. You will get 122 inches squared. So when you add it all up, this is your final answer, which is the surface area of the hexahedron or the rectangular prism. Okay, please remember it's called a hexahedron also because it has 6 faces. All right, so this is how you calculate this. Let's go ahead and calculate a triangular prism. Okay, triangular prism. So, all right, I am going to erase this. Okay, and okay. All right, so this is going to be a triangular prism, and I am going to say this is, and let me do one thing. I can go and do the back portion. Okay, this is 90 degrees, and then I am going to show you the back because the base, because you can see it from the top. It did not go very much like a square, did it? Well, that's my drawing issue, isn't it? Okay, that looks more like a square at the back. Whoa. All right. All right, sorry about that. Okay, So now, this thing at the back, it's supposed to be a rectangle, thank you. But normally when you're looking at it from the top, you can't really see the back. You can see this part, right? You can see this if you're looking from the top. Think about a tent. I mean, you can see the top part. You have to crawl inside the tent, then you can see this. But if you're seeing from the top, you can't. Okay, so that's what that signified by the dotted line. And let me make it easier for you so I can show you the front. If this is the front in green, the back is going to be the same measurement. Okay, let me make your one of the faces this color. And then let me make another face this color. And then the base is something that is at the back. Okay, so there we go. Now, when you have this given to you, let's put some value so we can calculate. Let's say this is 12 centimeters and this is 8 centimeters. This is 5 centimeters and let's say this is 13 centimeters. Okay, now once again, please remember that in a triangular prism, you have 5 faces. Okay, you have the front, you have the back, or you can count this at the base. It doesn't matter, base and top. But normally, because it's normally look at it like a tent. So that is why you have this is the front, this is the back. It's triangular. Okay, then you have this at the base, which is signified by the dotted line over there. And this is a regular one, but you can have something like that in which these faces are not always exactly the same. I'm just trying to see if I have any example over here, but I don't. But yeah, this can be more the rectangular measurement of the face. This can be less, and that's exactly what this prism up there is. But it is a triangular one because look at the front. It's a triangle, okay? So in order to solve this one, look, we have a side, okay? We have this side, which looks pretty big. All right. Then we have a bottom also, which looks kind of big. So, all right, so I'm going to make it like this. So this is the bottom. This is the side. Then I have another side, which, I should have done the bottom in a different color, but that's fine. I'm just going to show it to you. I should have made the other side red just because I had drawn it red, but oh well. Here's another side. Okay, let's just do this so you can see. There you go. Solves the problem. Okay, and then I have the back and front, which is triangular. Okay, and this looks more like an airplane thing going on with wings. Okay, so this is your back, behind, and then you have the front, which is here. Okay, so remember this has 5 faces, 3 rectangular, 2 triangular. Okay, that means I have to find those 5 faces. So I can easily do this also to break it apart, make it easy on myself. I know I have the side, I have another side. Okay, so this is side 1, side 2. I'm breaking it into 5 pieces. Okay, I have the bottom. I have your front and back. Okay, you have a front and you have a back. Okay, and then remember when we find the area of all this, after that, then you are supposed to add them all together. So I do front and I do back. And once I have all these areas, I am going to add them up to get the surface area. So it becomes really simple over here. Okay, so let's look at the first side, which is going to be my blue one. Okay, so if I look at this blue rectangle, okay, it has to be this length times this width. Now to calculate this width, I have to look at this rectangle. So if this is 8, this is also 8 centimeters. Okay, so the area of this rectangle is going to be 13 centimeters times 8 centimeters. Okay, so 13 times 8 centimeters is the area of this rectangle. All right, now let's look at the second side. You already, because this is written out and that's written out, this is my side, so this is going to be 8 times 5. Okay, so this is 8 centimeters, this is 5 centimeters. So first thing, always do one thing, that go ahead and write out all the measurements, and then it's easy to do the calculation. All right, now for the bottom, look, this is the rectangle. I have to look at this whole thing over here, which is this rectangular base over here. Okay, that's the bottom. So it is 12, and then this is your 8, and this should have gone a little bit more slanting, but that's fine since I made it just now. Okay, so 12 times 8. So this is 12 centimeters, and this is 8 centimeters. Okay, now let's look at the front. We have 12, and then if this is 5, I know that this height is also going to be 5, because that's what I have to look at a triangle. Because what is the area of a triangle? Base times height divided by 2. Okay, so this is going to be 12 centimeters and 5 centimeters. And since in a prism, the front and back, or the top and bottom, you know, however you see this, since we have 2 triangles, both triangles will be identical measure. So this will be 12 centimeters. And this is 5 centimeters. All right. Now, once I have all these measurements, basically I am just going to find the area of this shape based on the area of whatever the shape is. For example, for a rectangle, area is length times width. For a triangle, so this is for a rectangle, or you know, length times width. For a triangle, area is base times height divided by 2. If you remember why we said that, when I had taught you the lesson on 2D, here is my rectangle, and when I break it apart, what do I have? 2 triangles. That is why base times height divided by 2. So remember that always, okay? So now, let's do side 1. If I do 13 times 8, because this is a rectangle, this is length times width, and I get, it times 24, and so I get 104. Okay, 104 centimeters squared. If I'm doing the second side, which is the smaller one here, I can do length times width, because that's a rectangle also, 8 times 5, and I get 40. So these are all the measurements that I am going to need just now in order to calculate that surface area. Okay, then for the bottom, which is a rectangle, I am going to do a length times width, 12 times 8, okay, and I get 96. All right, now we come to the front and back, which are triangles. Okay, so triangle is base times height divided by 2. Okay, so I can simplify before I multiply. I have 1 here and I have 6 here. 6 times 5 is going to give me 30 centimeters squared. Whatever the measure of the first triangle, the second one is going to be identical, because both of them are exactly the same, because it's a prism, triangular prism. So if that is 30, this is back is also 30 centimeters squared. Okay, now in order to calculate the surface area of this triangular prism, all right, we are going to find right over here, area of bottom plus we have area of front, area of back, plus area of the first side. So I'll just call it of side 1 or something, plus area of side 2. Okay, then let's calculate, make sure we have the right number of faces. We should have 5 faces. 1, 2, 3, 4, 5. Okay, now when I have this, I will just plug in the numbers. So the area of the bottom was 96. Area of the front is 30. Area of the back is 30. Area of the first side is 104. And area of the second side is 40. Okay, so once I add this, I know that 96 plus 104 gives me 200, and then 40, 30, 30 is 100. So 200 plus 100, my surface area is 300 centimeter squared, because remember, surface area is in square units. So this is how you find the surface area of a triangular prism. All right, and now one last one, and honestly, this is the easiest. I mean, they're all easy, but this one is seriously easy because you just have to calculate 2 things and then do times 4 or whatever. Okay, so we are going to find the surface area of a square pyramid. Surface area of a square pyramid. Okay, so if I'm drawing the surface area of a square pyramid, you know, I'm not going to try to attempt that because it is going to be an effort right now, and I'm running short on time. So what I'm going to go ahead and do is I'm going to straight up show you the net. Okay. Well, if I have this, and if I have this, and well, if I go like, I should have gone till here. Let me do that. I told you this would take a little time. I thought like, okay, let me just go ahead and do it. Okay, so then I have this, and then I have this. Okay, there you go. It's going to take time, but might as well just do it. Okay, now if I have this given out to me, you will also have another line, because remember, in a triangle we've talked before, the height is signified by what is going from top to bottom over here. Okay, this signifies the height, not anything that is written on the side. So this height of the triangle is going to be 10 meters. And then if this is given to me as 7 meters, now let me show you how easy this is. Now, we know that in this, we basically have a square base and we have 4 triangles. So total we should have 5 faces, okay? So when I open this out, I have a square and then I have 4 triangles. Okay, 4 triangles like this. It's telling me the square, this is 7 meters, and it's telling me that this is the height, which is 10 meters. Okay, now don't come tell me that Miss Joshi, we don't have the other side measure. How do I calculate that for a square? It's a square. Okay, so if one side is 7, the other side, all 4 sides are going to have the same measure. So remember that, because it's a square. Okay, so we have over here, we're going to find the area of the square. If this is 7, since it's a square, all are going to be 7 because it's a square. Okay, now area of a square is side times side or side squared, length times width, whatever you want to say, okay? But so all we're doing is, please don't do 4 times 7, because 4 times 7 is something totally different. That's the perimeter. It is not area. Area is side times side in a square. All right, so I do area is 7 times 7, and I get 49 meters squared. That is for, the base of this. And then I look at the triangle. Area of a triangle is base times height divided by 2. My base is what? 7. My height is 10 divided by 2. And so I can simplify here, and I get 1 and I get 5. So my area of one triangle is 35 meters squared. So if this is 35, guess what? They're all the same. So this is also 35. This is also 35. This is also 35. That's why I was saying this is so simple. Okay? Now, when you're finding the surface area, remember there are 5 faces. You have the square bottom and you have the 4 sides over here. So surface area, in this case, you're going to have the area of bottom plus you are going to have area of side 1 plus area of side 2 plus area of side 3 and the last one, area of side 4. Okay, so what is the area of the bottom now? The area of the bottom for surface area, we have 49 plus I can do 35 times 4 because there are 4 of those, or I can do 35 plus 35 plus 35 plus 35. Okay, and so 35 plus 35 is 70, 70 plus another 70 gives me 140, and 140 plus 49 gives me 189. So my surface area is 189 meters squared of this square pyramid. Okay, so as simple as that, surface area, guys, is really simple. I'm telling you, break it apart into the different faces if you need to. First, you write out all your measurements. Then you find the area of each of the faces. And in the end, you just add them all up. So that's how you find surface area, which is what is outside, the area of outside a 3-dimensional shape. All right, and this concludes our unit 9, which was of indicators 31 and 32. Have a great day, guys.